circuit. Here we have a voltage source, resistor, plus minus. Okay, so current is basically the number of charges passed per second. The equation for current is actually given by delta Q by delta T. A Q is charge, that is measured in coulomb, time is measured in second, and then the unit for the current is given by ampere. Okay, and there's a law that says that Ohm's law that says V is equal to I times R. So from this one we can know the relationship between voltage, current, and the resistor. Like if the current increases, what happens to the voltage? You can see this voltage and current are directly proportional. If you increase the value for current, the voltage value is going to automatically increase. So you can say voltage also increase by current. If you increase the resistance, what's going to happen to the current? If you bring the resistor to the other side of the equation, you can see I and Ri indirectly proportional. So if you increase the resistor, the current is going to decrease. Okay, so this is the relationship between current, resistor, and the voltage. And from this equation, actually we can derive some more equation. Like we have another equation, that is power is equal to Vi, and power is equal to Vi. Using this equation, I can write the power in many different, like 3 different ways. Like if I plug IR for this V, this is gonna become I square R. So that's one of the equation. And also if you plug we have I square R, and if you rearrange this equation, I is equal to V over R, and then plug it for this I square, you're gonna get V square over R square times R. So R cancels, so you're gonna get V square over R. So these are 3 ways you can express power. Now let's look at a problem that we can use this formula to solve. Okay, here's the problem. A current of 3 ampere flows in a wire for 12 minutes. How much charge passes through any point in this circuit during this time? So they're asking for the charge, that is Q, and that is A. For the A part, we need the Q, and B, how many electrons would this represent? So we have to find the number of electrons. For B part, number of electrons. So let's find out the charge first. The given information is current. The current is given, that is 3.8 ampere, and also we have the time that is given in minutes, 12 minutes. And we know the equation that is related to charge and time, that is I is equal to Q by T. Since we are finding we want to find the Q, we have to rearrange this equation, that is Q is equal to I times T. We know that I is 3.8 ampere, but T is in minutes. But when we apply in this equation, we have to convert the time into seconds. We know that 1 minute contains 60 seconds. 1 minute is equal to 60 seconds. So to convert this 12 minutes into 12 minutes into second, what I have to do, I write 12 minutes divided by 1, and then 1 minute the denominator, because we want to cancel the minute, and then 60 seconds in the numerator. So minute cancels. 12 times 60, that is equivalent to 720. So this is 720 seconds. So this 12 minutes is equal to 720 seconds. Now we have the time and the current available, so we can calculate the charge. 3.8 ampere multiplied by 720 seconds, and that's going to give us a charge that is 2736 coulomb. Okay, so now we have solved the first problem, that is A, 2736. Now the next thing is we have to find out the electrons, number of electrons. To find out the electrons, first we have to know one electron contains how much charge. That one you have to memorize. So here one electron contains 1.6 times 10 to the power of minus 19 coulomb. This is one electron. So here we have 2736 coulomb. We have to find out how many electrons contains this charge. To convert this one, what we do, since we have a conversion factor right here, we know that we have to cancel this coulomb and convert into electron. So let's put it in that way. I'm going to divide it. So here 2736 coulomb, and I put a 1 in the denominator. If I want to cancel this coulomb, what has to be in the denominator? The coulomb has to be in the denominator, right? So I put the coulomb in the denominator, that is coulomb here, and the electron in the numerator. So 1.6 times 10 to the power minus 19, and then electron is 1. And if you solve for this one, you will find the number of electrons, because here the coulomb and coulomb cancels each other. So the final answer is going to be electrons. And if you solve for this one, you will get 1.71 times 10 to the power of 22 electrons. Okay, that's our final answer. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.